Welcome to this new episode where I show the GitLab source code that is used to make secure outbound network calls. I came across this code in the previous episode when I was looking at how GitLab securely delivers webhooks to all its users. So at the heart of it is this class called HTTP, which is actually bulk of the functionality is provided by a third-party library called HTTParty. So HTTP is including HTTParty features, but then decorating HTTParty with its own connection adapter called HTTP connection adapter, which is essentially the one that's taking care of security. So if we look at HTTP connection adapter, then we will see again that HTTP connection adapter is decorating HTTParty, the third-party library's own connection adapter, and before calling super, it is raising some security related error when the URL is blocked, and the bulk of the logic is done in the URL blocker. Found this part of the design within GitLab where they centralized all outgoing connections and added security on top to be a brilliant one. But let's look at the URL blocker itself, how it works. It has a validate method that takes a bunch of arguments to decide how to validate. We see that by default, calls to localhost is blocked, but calls to local network is true. I find that dangerous as a default. I would rather have it allow local network false, but otherwise those different configurations make sense to me. Now if you look at how the validation actually happens, it's defined in this validate URI method. The first thing it does is it validates if there is any HTML tags, which is often used in a URL to do a reflection based attack. So it will enforce sanitization in case you want that. Then it calls the internal URL, which checks for whether or not it's going to internal web or internal shell. I think these are special cases where it checks that if the call is going to GitLab itself, or if the call is going to an SSH call into GitLab's own infrastructure. Okay. Now going back to the validate method, see that it validates the ports. So let's see what it does. Okay, it basically checks that outgoing connections are made to a certain port or a specific range of ports. So in this case, for example, it will say the port is invalid if it is bigger than a certain number. Interesting. Then validate scheme, we skipped it, I think, but we can look at it. So if scheme is blank, if there is no scheme, so HTTP, HTTPS, FTP, something like that, or the scheme is not part of the expected schemes. So for example, if the outgoing connection is sent to an FTP, an endpoint, when only HTTP or HTTPS is expected, this will throw an error. Pretty cool validation for that. And then validate user, let's see what that does. Okay, so it's checking that. So validate user method is given the username, so you can encode the username in a URL, and it verifies that the username itself conforms to a pattern. So it will require that it's present, and it will require that it's an alphanumeric value. I actually didn't know that this is a common case where you have to have alphanumeric value, but maybe this is by the URL, like the URI standard. Just not familiar with it, so it's good to know. So the next thing is validates hostname. Let's see what it does. It checks, it is required, of course, for a network call to be made. It checks that the IP address is valid. And if it's not an IP address, it checks that the host name is an alphanumeric value. Cool. and then it does the validate Unicode restriction. So which basically makes sure that the URL is ASCII only. That's the only check. Okay, so this is the validate URI method. So this part is confirming that the outgoing URL itself is valid. Now let's see what happens after. So it validates the URL, then it validates the address information. That's where some of the other security checks are. So it gets the get address info for the host name. So essentially it's doing a DNS resolution for this port. And so after the host name information is available, then it's checking if it is IPv6 to v4 mapped, then it is converting it to v4, and otherwise just giving the address, which would be a v4. If it runs into an error by any chance, then it deals with whitelisting. So there is a way for overriding the error, I guess. Otherwise, it raises the error. Instead of raising a socket error, it raises a more meaningful blocked URL error with a more meaningful message, which is makes it easy for debugging. So it gets the address info, and then it must be present, and then it gets the IP address. So let's see what it does for the IP address method. So IP address calls the address info and takes the first one. This is the part where I find a little bit iffy, because the DNS name can be used for load balancing, which could resolve into multiple IP addresses. And even if one IP address is allowed, the first one, the second one may be pointing to a local infrastructure. So I think, I haven't verified myself, I think there is a potential for a security leak here, where some receiving domain can resolve to some legit IP addresses and some IP addresses that are actually internal that should be blocked, because GitLab is only checking the first one that they get from the DNS resolution. They may miss out on the other ones which may be used while actually sending the request. Other than that, this code is pretty good standard for enforcing fairly strict security measures when your system is used to make outbound network calls, so that it doesn't end up calling your internal resources that may not be otherwise exposed to the third parties. So essentially, privilege escalation or lateral movement kind of scenarios could be prevented by adding those extra security checks. I did have a good time learning about this code in GitLab. It was very easy to follow. It's a pretty good pattern that I want to bring in my own project. Thank you for your time on this episode. Hope to see you on a future episode. Bye for now.